Hi, everyone. Welcome to today's presentation at Virtual Pass. Um, my name is Janice Griffin, and I'm going to do this presentation on do you feel the need for speed in your SQL Server database? Are you frustrated with your tuning efforts? Before we get started, just a little bit about myself. I've been a long time DBA. I started out with Oracle version 3, if you will. I used to be an Oracle ACE director. I had to step down this year due to the COVID stuff. I couldn't keep up with a lot of presentations. But I am an Oracle ACE, and like I said, I started out with Oracle version 3. I've worked with many database types, all relational. I worked with what used to be Sybase, then became SQL Server, and MySQL and Oracle are my three strengths, although I worked with many other database types. I've always been a DBA. I've specialized in performance tuning at my own company for 5 years, and now I've been working at Quest for the last 2 years, actually working with our customers, our prospective customers, looking at their database performance and giving them some idea on how to tune it. And there's always that question of, well, how do I tune it? So that's why this presentation. So the agenda we're going to talk to today is we're going to talk about the challenges of tuning tips that I use. It's how I tune manually. And then I'll show you a quicker way. And we'll use several case studies to bring that all home. Please, if you have any questions before I get started, just chat them and we'll get to them at the end. Or, Jazz is helping me here today and he will let me know if there are any questions that I'll answer them along the way. Okay, let's just face it, SQL tuning is hard. A lot of times it's trying to figure out who should tune. A lot of people think the DBA should tune, but the DBA is often just focused on keeping the lights on and keeping things running. And they don't really know the application. A developer should be able to tune his own code, but a lot of developers are Java developers. They don't even know how to write SQL. They use third-party SQL code generators to actually create that SQL. And that's why SQL can be really poor if you're using a code generator. Oftentimes finding which SQL it's going to give you the biggest bang for your buck to tune is a hard thing. There's lots and lots of SQL statements in the database, and knowing which one everyone's waiting on is often hard to find. And then I think tuning requires a lot of expertise. You need to know how to read an execution plan. You need to know what the best data access path your query should be using. You need to know the different join methods and which one's the right one for your query. Also think you need to know how to write good SQL because a lot of times you have to rewrite the SQL in order to make it run faster. I also think it's important that you know the business reasons for that SQL. What's its purpose? Who's using it? How often does it run? I can't tell you how many times I've seen developer write a piece of code thinking it's going to be run once or twice a week, and it's run millions of times an hour, and they're surprised. I also worked for an accounting firm years ago, and it was responsible for a finance database. And every month then they yell at me about how slow the database was. I got to looking around, and here this accounting clerk inherited this job of running these month-end reports. And when I asked her what she was doing with them, she was just filing them in a filing cabinet, and nobody was using them. So that was the easiest tuning gig I ever did, was just shut off those reports. Tuning takes time. Like I said, lots of SQL statements, and there is no cookie cutter approach. And then finally, low priority at some companies. Some people just think they can throw hardware at the situation, but poorly written SQL just consumes resource. And as the data grows or the workload changes, it's just going to, it might buy you some time to throw hardware at it, but it's just going to eat that hardware up. And then finally, tuning is never ending, which could be a good thing if you get good at it. Okay, so here are my tips. Tip number 1 is monitor wait time. And what I mean by that is SQL Server, as with many of the other database types, they've instrumented themselves to actually record not only the total time a SQL spends in the database, but also each step that SQL request goes through. And it records the time of that step. It actually records the resource that is waiting on or using up. It does this by SQL Server providing wait types. And so if you were to collect that information and store that off, you could go back real quickly over time and not only see current wait time, but you could go back and see what SQLs are your end users waiting the most time on. And it'll give you great clues on how to tune, because wait types usually have a solution on how to tune them. Now, if you wanted to build your own tool, it's simple to do. The DMVs, what they're called is dynamic management views, and they're real-time tables that sit in memory that just hold performance data. Now, this is not a comprehensive list of all the DMVs, but this is the information that you would gather out of these tables. It's not even all the columns in these views, but this is the information that you would gather, and you'd actually store this off into a table, and that's what you can go back and look from. Now, what you would do is you'd look at DM exec requests, and there you can get the SQL handle, the plan handle, if it's a stored procedure, you get the stop and start offset, you get the database ID, the user ID. If it's a blocking session, you can get the blocker, you can get the wait time and the wait type. So you can get all that information. You join that into DM exec sessions to get the program name, the login name, the host name, the session ID, and then you can join that into DM exec query stats to get the logical and physical reads and writes, execution counts. You can get many more columns than just what I've listed here. And then finally, you can also join it into these table value functions, DM exec SQL text to get the actual SQL text, and DM exec query plan to get the execution plan. Now, if you want to see the whole instance level, you can go into DM OS wait stats, which I have on the following slides, some examples of that. Now, hopefully no one is on 2000 anymore, but if you are, for some sad reason, you can still get a lot of this information out of sys processes. So you're not dead in the water, but anything earlier than that, you can't look at wait time. Okay, wait type, the problem with DMVs is they're not time-based views. They're since the system startup or since the table or the view has been last flushed. So you can't go back in time. You can't say, you know, what happened between 3 a.m. and 5 a.m. this morning. It's not possible with the DMV objects. But what you can do is you can use other tools. I can show you how to make your own tool by running the query on the next slide. All you have to do is include a timestamp and the information on the DMVs and save it in the table. You can look at extended events, the system health session, which started out in 2012 and above. That actually gathers SQLs and wait types. However, it's hard to see trends over time. And then Query Store actually came out in 2016, but 2017 had the weights. Didn't have weights in 2016. So, but in 2017, you can get the weight types. And then, of course, our products, Quest Foglight and Quest Spotlight, they also show weight and the resources being used up. Now, like I said, it's not rocket science. If you want to build your own tool, all you have to do is go to DM exec requests. And like I said, it's a real-time view into what each SQL and each session is waiting on. And you actually look at the status column. And if it's suspended, it means the session is waiting on a wait type. If it's running or runnable, it means it's either on the CPU or in the CPU queue. And if it's sleeping, it means it's idle. So then you just select this information. And notice my query. I'm selecting session ID, wait time, status, wait type, blocking session ID if it's blocking. I get the text. And if it's a stored procedure, I get the start offset and the end offset of that query. And then I get the execution plan. And I actually get that from DM exec request. I outer apply it to DM exec SQL text, passing it the SQL handle, and outer apply DM exec text query plan, passing it the plan handle, and the statement start offset and statement end offset. And then look at what I'm excluding. I'm not looking where any processes are background, because that's just noise. Same way with any processes sleeping, they're idle. I don't need to look at them. That's just more noise to look at. And then I'm also excluding myself because I'm going to pull this information at some interval. I like to poll every second. It depends on your database. If you have very highly transactional data, you might want to poll more than a second. If it's a data warehouse, you may not need to. You may just poll maybe every 10 seconds or every 30 seconds or maybe once a minute. But when you pull that information, then you can go back and you can run a query to give you what is actually running and what is the sessions are waiting on. So as you can see here in this example here, I've got one running, I've got 3 in runnable state, and I've got 1 suspended on async network IO. Right away, that tells me that it's it's talking to the client and probably passing too much data to the client. Now, I didn't poll this for very long, but you can actually see the SQL text and the execution plan. Now, if you want to see, say you have 50 or more instances that you're responsible for, and you just want to get the lay of the land, you can look at DMOS wait stats. It's cumulative, like I said, since instance startup or since it's been last flushed. Now, you can use DBCC SQL perf, pass it the DMOS wait stats view, and say clear. And what that will do is it'll clear it for right now. So say you come in and everything's gone south and you don't know what's going on. You could actually run this command and then actually run the query on the next slide and actually see where all the wait is occurring. Now you can see my example here. I ran it and this one VM that I had, I spent 80% on a lock. So I had a blocking problem, quite a big one in this whole instance. This is a 2012 idle events here. This is on the web. I think Paul Randall put it up. And I think in the appendix in these slides is the 2019 one. It's actually several pages long now with all the idle wait events. But it's basically the same query. It just has more idle waits. So as you can see here, I'm selecting all that information from DMOS wait stats, excluding all the idle events. And then I did a little CTE to actually, get that information. And so this VM spent, 52% on SOS scheduler yield. So that was my top weight in that whole instance. Now, like I said, the session level information is not rocket science. You can actually run this query. And I first created it with, I'm kind of lazy, so I created it with a select into my RTA data table. And I'm just selecting all that information I had in my first query and adding timestamp. And then I'm just, you see my where clause is the same. And then I just run this insert into RTA at some interval. And like I said, I like to do it every second. And then turn around, I use this little CTE to actually, write and get the data out of it. So on the next slide, you can see, I did this for about 3 minutes. I had like 5 sessions running. And as you can see, I ran this query and actually looked at my data that I collected for 3 minutes. And you can see I had almost 5 minutes on this one query. This is my top query in the database. Now, of course, you'd want to poll longer. 3 minutes doesn't really tell me a whole lot of information, but if you do it 7 by 24, you'd be able to go back over time and see as well. But as you can see, this one select p name query actually waited a total of almost 5 minutes, and it actually spent 2 seconds on async network IO, over a minute on IO completion, and then the rest of the time on CPU. So right there, I've got some great clues on how I can tune it. Now, if you wanted to use extended events, so this is a 2016 example, but basically, you just, the system health is on by default when you install SQL Server, and it actually writes to a file, and you can actually query that file in Management Studio. And you can sort and group by, and actually, I actually sorted by SQL text and wait type, and then I sorted aggregation descending so I could see my top weight in my instance. So IO completion was my top weight, followed by resource semaphore. Here's an example of the query store in 2017, and there's a new view here called Query Store Wait Stats, and that's new in 2017. So you can actually run this query against the query plan tables. Now the query store is not turned on by default, so you would have to physically turn it on. But as you can see, my top SQL statement here is waiting over an hour on parallelism. Okay, and this is just an example of Foglight. I can focus on a SQL statement. What I love about Forglight is basically it sorts the SQLs by the one spending the most time in the database. So this one top statement here happens to be actually a case study we're going to go through. And it's actually a university came in and actually called us to help them with their billing. And so they were selecting first name, last name, and sign-up date. And we'll go through the query in a bit, but you can see it's my top query in the database. You can see it was waiting most of the time, 86% on a network wait. Now, as I go down here, notice I can also get my baselines. And I always like to get logical reads as a metric to collect and to compare against as I tune. Because if you can reduce logical reads, you actually can improve your query. If you think about it, every query has to do at least one logical read. It may not have to do a physical, but it has to do at least one logical. So if you can reduce that, that would really speed up your query. So, excuse me, that's a benefit. And I like to get the baseline metrics. I also like to figure out how long does it take now, and then I like to plan to see what's acceptable. And the reason why I do that is because when I first started tuning, I didn't know when to stop. I drive myself nuts. So find out what is acceptable. If it's taking 10 minutes and you want to get it sub-seconds, that's probably doable. But if it's taking 10 hours and you want it sub-seconds, that might be more than a tuning session. It may be a re-architecture or a rewrite of the application. And then, of course, I always like to get logical reads. Okay, so, and I also like to look at all the wait types. Now, you may have more than one wait type in a query. And I usually, what I do is look at the one that it's waiting on the most and start tuning for that. And then I work through the list. Sometimes the other wait types will go away as you tune. Sometimes they don't because a lot of them have different resolutions. So as you can see here, here's my baseline metrics for that one query. And we did 4,955 executions. Quite a few logical reads, 2.2 million. It was not too bad at 0.26 seconds at running, but still, it was my top query running in the database. The great thing about wait types, they give you great clues. We have if you go out and Google Waitopedia on our Quest Waitopedia, basically what we do is we ask our customers from Spotlight Cloud if they'd like to opt in and give their performance data, to us. And then we actually share it with our customers and with the public by putting it out on the internet. So you could Google, Waitopedia, and you could look up the async network IO or whatever weight you're interested in, and it'll tell you how popular, how common it is across our customers, as well as give you solutions on how to tune it. Other benefits of monitoring wait time are you can quickly find changes. Now, this is a case of where an execution plan changed. And you can see the exact time it changed. And we can actually go down and see what it did. So at 5:23 p.m., it was a table access full. Before that, it was actually being accessed by an index. So, of course, the time crept up on that one query. Okay, you can also see blockers and waiters. And you can see the exact time it started blocking and how long they blocked. So here you can see that this SPID 65 is blocking, and it was actually blocking this SPID 69. And you can actually get the SQL statements that are involved. Okay, so these are my top 5 manual tuning tips. I like to monitor wait time. I look at the wait events, record baseline metrics, and get the SQL that spent the most time in the database. I review the execution plan. I look for expensive steps. I know what's supporting the plan. And then I gather object information for those expensive objects. I want to know what the optimizer knows, what's supporting that optimizer, And I want to, actually analyze the objects to look at the cardinality, the selectivity, all of that. Look at the indexes, the table sizes, so on and so forth. And then finally, I like to find the driving table. What I mean by that is I like to get the least amount of data first and then build on it in a query, instead of reading and joining all the rows together and then throwing them away at the end. That's wasteful. So I use diagramming techniques, and I'll show that a little bit as we walk through these case studies. And then finally, my favorite tip is engineer out the stupid, because a lot of times people do stupid things when they're busy and trying to meet a deadline. I don't know about you, but I know I've had to meet a deadline and I just get the SQL running, not looking at things to make it run more efficiently. And so you can really get yourself in trouble in doing that. Okay, there's another way to tune, and this is what I'm excited about to show you, is you can use Forglight and SQL Optimizer. There's only 2 tips you need. Tip number 1 is monitor wait time. Find those queries, spend the most time in your database via Forglight, and focus on the wait events and the baseline metrics. And then tip number 2 is tune the query via SQL Optimizer. SQL Optimizer can basically tune a query in 2 ways. It can rewrite the query, which you give it the query and it says, okay, I'm going to rewrite this and get the least expensive execution plan. And it'll get you, it'll actually do it a number of times, and you can actually configure it to do it 50 times or 100 times, however many rewrites you want it to do. And it'll rewrite it, and then it'll put a little gold cup at the best execution plan and the best query. And how it does that is it rewrites the data access paths, the join methods, in order to arrive at that. The other way the optimizer will tune is you can tell it, okay, I want you to look at the indexes. What are the best indexes I can put for this query? And it'll go through and do the same thing for that. And I'll show that in our demo. Okay, so here's this case study I alluded to before. And this was, like I said, came in from a customer. They were a university. We're simply trying to get their billing out. And I've changed this somewhat to be kind of more relevant for my presentation, but they're trying to answer the question, who registered yesterday for classes? I've changed it for SQL tuning to be specific. But they were selecting first name, last name, and sign-up date from student. And they were joining that on registration on student ID. And then they were joining it on class ID. And they were looking for the class name equals SQL tuning, and where our sign-up date was yesterday, if you will. And registration table was historical by nature, so they never deleted from it. They actually, if a student dropped or canceled a class, they actually marked the canceled flag to Y, so it would be archived. So they were looking for only current records. Now, like I said, we found this via Forglight, being the top SQL, and it was running in this instance of almost 2 seconds. It had 3 million logical reads, and it spent most of its time, 78% of its time, on async network I/O. Async network I/O, if you go to the books online or Wikipedia, what it is it's sending a lot of data to the client, and the client can't usually consume it fast enough. So we're going to go into the demo and show you how SQL Optimizer works. Okay, so here's my query. And we found this by way of Forglight. So as I come into Forglight, you can see it's in the top here. It's not the top one. But as I come in here, I can take any of these statements. And this happens to be another case study for me. But I can come in here and I can analyze the plan. I can see my baseline metrics. This may take a little while. Okay, there I can see the plan. I can actually put it in the Management Studio, get the graphical plan. I can, Forglight does a little further analysis by telling me the most expensive step, as well as it does some information on the objects. And then basically what I can also do here is I can tune the query. When I tune the query, basically it creates this little SQL Optimizer file that if I open it up, it'll open up in SQL Optimizer. So this is SQL Optimizer. And what I did is I said, optimize this query. And it actually went out there, and I did it a number of times. I know this is kind of tiny print, but if you look out here, you can see all the alternatives it did. It did, 34. And it actually went out there and it said, okay, the original was taking 0.12 seconds. And I can show faster, and you can see my one with the little gold cup. It had tuned it down to 0.009 seconds, so much faster, much better. Now I can say, well, what did it do? And so you can actually compare. And when I compare, it's going to show me the original and then show me the one with the gold cup. So I can actually grab that one. And then you can see the rewrite. And what it basically did here is it actually did a +0 on the class ID. And that basically turned off that index that it had. So, and it ran much faster that way. Now I could stop there, 0.009 seconds is pretty efficient. I should be happy with that. But I wanted to see what it would do if I told it to optimize indexes. So I came in here and I said, I want you to optimize indexes. So basically I came back here and I said, optimize indexes. And then it did it for a number of times. I guess it made 9 indexes. But look, it's got a little gold cup at this one. And instead of doing 0.011 seconds on the original during this run, it did 0.001. So that is the best one. Now I can look at the plan and I can compare. It didn't rewrite the query. The query is the same, but instead it added the indexes. So we can actually go look at the plan itself. And we can see, let me see, I've got to go back and get the actual right ones. It's not comparing them. Okay, and then I can go look at the plan. And you can see it actually created an index on registration called, and all of Optimizer's, SQL Optimizer's indexes are prefaced with an OPT under SX under IDX prefix, so you can quickly identify it. So it created that on registration, and so we can come back here and look and see exactly what that index looks like. And you can see it added an index on class ID, canceled, and sign up date. And we even get the script here to see. And you can see that it put it all in here. So that would be what all I'd have to do to optimize this query. Pretty easy. Okay. Did we improve it? Well, yes, we did. It's 4 times faster and 3 times the throughput. The thing about wait time analysis, you also can start comparing to different baselines, to different time frames. And so what I did was I actually found this query and I compared it to before I actually added that index, and you can see that it did improve it by quite a bit. It was running 5 seconds on average before, just chugging away. I usually have 5 users just running the query over and over again, and it got it down to 1.3 seconds. And look at my throughput, 59 executions up to 160 executions in the same time frame. Okay, this is case study number 2. And basically what this is actually going to AdventureWorks. And I made it a little more meatier because I'm going to walk through my 5 tips to kind of show you how I do it. But I'm getting customer information and order information from sales order header, joining that into customer on customer ID. And then I join customer into person on business entity ID to person ID. And then I join order detail on order ID to order header ID. And then I join production product on product ID to order detail product ID. And look at my filtering predicates. I'm looking for Online flag equals 1, so I'm only looking for online orders only. I'm looking where last name like C%, product name like mountain percent 42, and product ID like 9%. So a lot of likes, a lot of complex predicates for the optimizer. I found this via Foglight using wait time analysis, and you can see there's in my top query spending 97% on CPU, so very CPU intensive. And typically, queries shouldn't be CPU intensive. SQL Server shouldn't be eating up a lot of CPU. If you find that you have instances doing that, then look at your logical reads. 10 to 1, you're doing far too many logical reads, and that's just crashing not only memory, but it's actually taking CPU cycles. So we can see that this my baseline metrics, I actually got 439 executions, but look at 92 million logical reads. Quite a few rows, 390,000 and some, but still a lot of logical reads. We go get the execution plan. And as you can see, I always look for the expensive steps. And as you can see here, I have quite a few. I have a key lookup in the product. It's using an alternate product name index, but then it has to go back to the table. And that's what that key lookup is about. Then I also have a clustered index scan. So that's pretty much a full table scan. It's an ordered scan, but still it's reading the whole table. And see my thick pipe here. That's actually reading lots of data to that next step, and that's doing a hash match. And then I have another index seek, but it's kind of a high count and a thick pipe again. And then I'm doing another clustered index scan. Now the index seek is the best you can get. But the reason why I've circled that is it's still kind of a thick pipe. And when I always like to gather the logical reads, so I set statistics IO on, and you can see my order header was 126,821. So quite a few rows were being, blocks or IOs were being done for my logical reads and sales order header. 79,270 logical reads for sales order detail. I also have a little caution sign, which means something's up with one of these steps. So that's something to note as well. I go and get the object information. And so I look and review the table sizes and the indexes. And you can see my table sizes, the tables aren't very large. Products, my tiniest, 504. Sales order detail is, like I said, about 8 million. And then sales order header is 2 million. So as I look at the indexes, you can see I do have a cluster key on product ID. Why isn't it using the cluster key as opposed to using that AK product name? And then also I have a index on last name. So why was I doing a full table scan on person? And then finally, you can see I do have indexes on sales order header and sales order detail. I like to go find the driving table, and I like to use a technique called SQL diagramming. It's kind of an old technique, but I find it works in every database type I've ever worked with. And it just works for relational databases. And basically, if you want to do SQL diagramming, how you do it is you draw this upside down tree. And so here I've drawn my upside down tree. I take at the top of the tree, I actually have the detail table. And so order detail was my detail table. And then you draw these links or arrows out to the lookup tables or the related tables. So I had order detail, had 2 lookups into order header and into product. I had order header had a lookup into customer, and customer had a lookup in person. Now the numbers on the lines of these links or arrows are basically the amount of rows that have to be joined to return any one person to a customer. So that's a 1-to-1 relationship. For a customer order header, that would be a 1 to 105 on average. And then order header to order detail, there's 1 record for order header for 246 records on average for order detail. Product, there's 29,000 and some for every product. Now, you should never have to read more than these numbers added up to return any one product or any one person. If you are finding that, that means your joins aren't indexed. I usually don't do this in reality, do these numbers on the arrows, because if you just ensure that your join columns are indexed, the optimizer will do the right thing. The more interesting query is these underlined numbers, and that's the filtering criteria. So as you come in here, we had 3 filters, one on sales order header where order flag equals 1. And you can see that wasn't very selective. Almost 88% of that table would be read. And that's 2 million rows. So that's a lot of reading to get that, to use that filter. There was one on person, and we had 7%, if you round up, of person would be read. And then we had one on product, where name like Mountain 42 and product ID like 9%. And 0.6% would be read from product. And if you remember, product was only 504 records. So that's my best filter right there. I want to drive with that. I want to drive by product. So, but the question is why isn't it using product, our cluster key? Because we do reference product ID in here. Instead, it's doing that key lookup and using the name index. I'm still not using last name in my person table as well. So let's go figure this out. We look at the key lookup and we look at the predicates of that step, and you can see there's an implicit conversion. It's actually changing product ID in the table to a varchar. It's actually changing to a varchar, and it was an integer. So. And the reason why is because I was comparing it with the varchar. So it had to, I gave it no choice. So it couldn't use that index. So that's why it went and used the AK product name index. Well, this brings me to my last step, is engineer out the stupid. And, really, you look for performance inhibitors. You cursor or row by row processing, never good for relational databases. Parallel processing, not that it's not always warranted, but a lot of times in OLTP environments, if you leave degree of parallelism on, what happens is it'll just eat up all the processing because SQL Server see that query as expensive, and the default is unlimited parallel processing. Hard-coded hints, they often get forgotten, and as the data grows, they're no longer valid. Nested views, or linked, and especially if they're going across linked servers. Abuse of wildcards or nowhere clauses. This is one thing the code-based SQL generators do a lot. They try to do all the filtering on the client, which really kind of ties the hand and the efficiency of the database. That's what databases are good for. And then implicit data conversions. That was my stupid. I'm doing an implicit conversion. Non-sargeable, where it isn't indexed, or you turned off an index. I seen this from a customer the other day where they were doing an upper, I think it was last name, but they were turning off the index on that column. So I engineered out my stupid by going and looking at the data, and product ID only went up to 999. So I could just change my query to be product ID greater than or equal to 900. And that gave me the same result set. And then, of course, it did the right thing. No implicit conversion. It actually did a seek on product ID. And, it became very efficient that way. The next step was to look at, we got rid of a key lookup. But the next step was to look at sales order head ID and sales order detail. And I decided to add this index. This was actually suggested from Management Studio. And it said, add this covering index on order detail, product ID, and also include order ID and order quantity. So I did that, and look at my logical reads. It's now actually doing a seek and brought the cost way down to 2%, and it's only doing 116 logical reads as opposed to, I think it was close to 80,000 before. Now, the next kind of thing that I always ask myself when I'm done tuning is, consider adjusting the indexes, rerun and check runtime details, compare the results with the baseline metrics, and then look at logical reads. And if did you improve it, then rinse and repeat. And so I still didn't like this high cost on sales order header. And the amount of logical reads were awful. So I decided to add a covering index on order header. And I did it on online order flag, and I included all the columns, order ID, order date, customer ID, and subtotal. And I brought that logical read down to 6,000, well, about 7,000 if you round up, which was 127,000 logical reads before. So did we improve it? Yes, we did. Basically, you can see, the response time went from 1.15 seconds down to 38 milliseconds. Throughput went up from 439 to 629, and in fact, it actually stopped early because I did improve it. And then the logical reads went down from 92 million to 4.5 million, and the throughput was 1.5 times better. Okay, so let's go see what Foglight and SQL Optimizer will do. Okay, so first let's have it rewrite it. And as I do this, you can see here's my query. And here is the part where I engine out the stupid. Now, I don't think it would, actually change that. I think you still need that step sometimes. But as you can see here, it did do quite a bit of rewriting. In fact, how much did it? We did 100 sessions and rewrote 100 of them. And when it did this, you can see the best alternative was 98. And so, let me see. Okay, the original was 1.5 seconds. And we get down here to 98. And you can see that brought it down by half. 784 milliseconds. So we can actually go see the comparison of that. And of course, you can see the execution plan, which it was an adaptive plan and used parallelism. It just had different costs. Let's see what it did for the rewrite. You can actually look at both the execution plan and the text at the same time, but I think it's easier to not do that. I like to see them side by side like this. Okay, so now we can see the rewrite. And what it basically did is it changed last name like, and then it's C, select C%. And then it actually included sales order ID, and it did this greater than or less than sales order ID instead of equal to. So, but that actually sped it up by half. Now I could stop there again because that, 700 milliseconds is pretty efficient for that query, but let's see what it would do if I added indexes. So again, we go over and look at the indexes, and it did a number of them, but it actually ended up with this one. And the original one was like running over a second, but it got it down to 276 milliseconds, so much better. And what did it do? It actually did it put an index on sales order detail, and it made it covering. So it put it on sales order detailed product ID and included order quantity, and it stopped there. And I didn't put anything on order header, which was interesting to me because it did get it down quite a bit without adding that extra overhead for an index. And of course, we can go see the plan to see what it added, and you can see the index right here. is where it did it. And it changed it from nested loops, from hash match to nested loops, which is typical for a lookup, detail table to a lookup table. Okay. Okay, so the next case study, this is kind of an interesting case study. I actually got this information from the Department of Transportation. And you can actually download, they download an Excel spreadsheet. So it's kind of a tedious operation, but you can, I don't know how far it goes back. I know it goes probably back into the 1990s at least, but you can get every flight from every city in the United States for every year and download it and load it up into a database. And it actually creates a star schema, which is kind of a fun thing to play with. If you haven't played with a star schema, I would recommend looking at this data. But I actually downloaded the data, loaded it up in SQL Server, and actually wrote this query, this little stored procedure here, where I'm trying to get flights by city and day of week. I wanted to see what was the most popular cities and on which days most people flew to those cities. So my little stored procedure, it was get city day flights, and I'm passing in begin date, end date, city and day of week. And I'm selecting from, and it's a fact, star schema has a fact table and then a bunch of lookup tables. So the fact table was T on time, and I downloaded the whole year of 2015. And then I joined on these lookup tables into the unique carriers, the originating destination point, the originating airport and the destination airport, the originating city and the destination city, and then the day of week. And then I pass in my filtering predicates for flight date between begin and end date and day of week equals the weekday, and a description equals the city, the originating city. Here's the schema, and as you can see, it is just a star schema with my fact table there and then 4 lookup tables. Oh, and by the way, you can download with that link in my slides, that data if you'd like to, replicate it. Okay, so here we found this one as being the top query in my database. It was spending all of its time on other, 57% of its time. It actually was taking almost 16 seconds running. It actually did 12 million, almost 13 million logical reads, and it spends all of its time on a CX packet. Now, if you go up and look up the CX packet weight, basically CX packet weight is really a status. It's not necessarily a problem. It's what the coordinator is waiting on while it has all its worker bees go out and do the actual work. So it's just telling you that it's doing some parallelism. What you have to do is you have to go look at what the worker bees are waiting on to see the weight that is actually occurring. So you go to DMOS waiting task, and you actually put in the session ID of the actual coordinator, so the person waiting on CX packet. And so you get this lower level of view of what the worker bees are waiting on. As you can see here, I have these 3 waiting on a latch. And if you look this up, and Paul Randall has a nice article on latching, you can see that this access method dataset parent really points to max DOP, and it's saying that the max degree of parallelism is set to 0, which is unlimited. So it saw an expensive query, and it said, well, this is set to 0, so I can just put as many processes to this as I need, and it chose all of them. And of course, that's what it did. When I went and got the execution plan, it was unreadable. In fact, it was this tiny. I had to zoom in to even get this little bit. I don't know how many, 300% or so to actually be able to read it. And as you can see here, it was parallelism, table scan, parallelism, bitmap. It was just over and over and over again. So, definitely, a problem execution plan. When I went to look at the table and column info, you can see basically, if you look at objects and join them on sys partitions, you can see whether it's a table function, a user table, or a view. And and if you look at index type, you can see the 0 is a heap. So I stupidly loaded these in to SQL Server with Excel spreadsheets and didn't even look at adding indexes. So this is my stupid part of it, is that I actually needed to add some indexes. So it took me a while to figure out the indexes to add. So I found all the clustered indexes, and it took me a while to figure out what the unique key on time was. But I actually added all those indexes, and then I actually turned off parallelism by doing exec sp configure max degree of parallelism 1. And then I reconfigured it with override. And as you can see, now all my tables are actual clustered indexes. Go find the driving table, and we had a few filters, but none of them were very selective. As you can see here, I had a one on time between a for flight date, and you can see 8% of that table, which was my largest table, was going to be red, and so that's not very selective. I had one on city market and originating city, and that was very selective at 0.02. And then I had one on weekday, which was 13. That wasn't as selected. So I want to drive it with originating city. So I look at the execution plan. I have this little problem here with the select. And so you can see I'm doing a clustered index scan on city market, which I didn't want. I want to drive with that. But I'm doing a seek on time, but notice my implicit conversion. I'm actually did date time. I actually loaded this up. I did, and actually it was all varchar. So it's actually changing it to date time in order to do that comparison with the date. So I fixed the stupid by just renaming the table and making it a date time. And then I added this index on city market because I wanted to make sure it was driving by that. And as you can see, it's doing an index seek. I got rid of my implicit conversion, and there is no parallelism. It's doing nested loops. So did we improve it? Well, yes, we did. Instead of, I think it was 97% on CPU, or no, on other. No, it was 57 some on other for parallelism. Is now waiting on a network wait, 52% on async network file. It went down from 16 seconds to 0.25 seconds, and it actually throughput went through the roof. The logical reads came down, but look at how much it actually increased in performance. So we did improve it. Okay, so let's go see what Foglight would do in this, and SQL Optimizer would do in this scenario. As we come up here, let's see what it would first do without with the rewrite. So as you can see here, it actually turned off the parallelism. And it gave with index 0 on time. So it did know that it shouldn't be doing parallelism. And how many times did it rewrite it? Quite a few times. 95 is the top one that I saw. And the execution, you can kind of see what it's doing. Still, it didn't do anything because it was, it had no indexes, so it's still doing all table scans, but it did know enough to turn off the parallelism. Now let's go see the details. That one was a little better. Let's see how it ran. Why my page is so small all of a sudden. Here, let me move this up. Okay, this is now 350 milliseconds. The original was 2.2 seconds. So it did improve it. Now let's go look at the index. What indexes it chose to add. And so it actually came up with 5 indexes, but on this run it did 2.8 seconds. The original. Look at what it got it down to, 54.054 seconds. So that's a pretty good rewrite or index. Now we can actually go see that index. And it actually added several. It added one on my city market, which was great. That's what I wanted to do. And then look what it did. It actually put one on time, and it did a covering index. It actually put it on it did it on origin city market ID and flight date, and then it included day of week, unique carrier, tail number, flight number, originating airport, destinating airport, and city market destination. So but it improved it without me having to go waste any brain power. So this is how well it did. It was going from, 16 seconds here to 47 milliseconds. So, I'll put this up. 47 milliseconds. And then basically it gave 8 times better the throughput. When you look here, it was 335 executions, and now it's like 2,653 executions. It was so good that this gray area couldn't fit on the chart. It was well above here somewhere because it really reduced by so much. So finally, you want to monitor the improvement, be able to improve that tuning made a difference, take new metric measurements, compare them to the initial readings, brag about yourself, as no one else will. I've never seen anybody come to my door and say, "Oh, thank you for tuning that." They don't really do that. So make your tell people what you've done, and then monitor for the next tuning opportunity. It's an iterative process. There's always room for improvement, and make sure you tune the things that make a difference. And then try out Foglight or Spotlight. We actually have a 30-day trial for both of those. And you can actually kick the tires and see if it actually helps you too. In summary, there are a lot of challenges in tuning. You can use my manual tips. They're tried and true. Like I said, I've done not only in SQL Server but Oracle, MySQL, DB2, and what used to be Sybase. Monitor the wait time. Excuse me. Review the execution plan. Gather the object information. Find the driving table. And engineer out the stupid. And then, or use Foglight. Foglight will help you find the queries to focus on and give you great clues on how to tune, and then tune the query with SQL Optimizer. You can either do a query rewrite or you can optimize the indexes. Okay, I'll take any questions.
Hi, Janice. So we have one question here. In your example, you showed that the max DOP, you changed the max DOP to 1. Doesn't that impact all queries running on that SQL instance? Should it be modified per query instead?
Yes. Since this was I built this just for these case studies. I just turned it up at the instance. But yes, on a production database, you would look at the query and give it a query hint, much like the optimizer did when it actually rewrote the query.
Thank you. I think that's all the questions we have at this time. And if anybody else has any questions, please ask in the question pane.
We can wait a few more minutes.
Yeah.
I should say I haven't uploaded my slides yet. I will do that after this. So if you're looking for my slides, please give it a day. and give me some time to actually get them uploaded.